Hello, ladies and gentlemen. My name is Adriana Bondarenko, a fourth-year bachelor student of architecture. This work was developed jointly with professor at the Department of Urban Planning of the Odessa Academy of Civil Engineering and Architecture, M.Shyshkin Mikhailo Ivanovich. As an architect, I became interested in the issue of coastal slope development, which has become extremely relevant, requiring a comprehensive approach and careful study. In this work, we conducted an analysis of natural factors, including coastal landslides and ongoing marine erosion, which pose a serious threat to the loss of coastal territories. Specifically, our research aims to explore innovative approaches to architectural design focused on protecting and restoring the stability of coastal slopes. Considering the complexity of the challenges, we examine key aspects of urban planning concepts, including the provision of aesthetically justified and resilient architecture solutions. Additionally, the paper delves into constructive solutions designed for the long-term operation of coastal construction objects. Eliminating these aspects is a crucial part of the research as they define the scientific direction of the work and indicate opportunities for further advancements in the development and protection of coastal areas. The work makes a significant contribution to understanding addressing the issues of natural degradation of coastal slopes through architectural innovations and constructive approaches. Architectural integration of buildings on coastal slopes presents a challenging task that piques the interest of architects and designers due to the unconventional and often demanding nature of the tasks they face. The modern construction industry encounters a myriad of complex challenges related to engineering improvements of coastal slopes. Research in the field of coastal slope engineering holds significant importance for the development and implementation of innovative technologies aimed at ensuring the stability of structures and preserving the natural environment. The development of such research will help address pressing issues associated with coastal erosion, ensuring the stability of construction works and reducing their negative impact on marine and coastal ecosystems. Houses situated on slopes become distinctive focal points of architecture exploitation, given their ability to harmoniously blend into the natural landscape, facilitating a more organic preparation for the composition as a whole. Over 17% of the population prefers hillside homes, drawn to the architectural uniqueness and complexity which manifests in their organic integration with the natural landscape. A key aspect of appeal of such hillside homes is the opportunity to enjoy picturesque views of the sea, lakes, rivers, forests, and mountains, providing aesthetic pleasure and panoramic observation points. Innovative landscape design solutions become an integral part of the overall image, creating an attractive landscape with relief, variations, and slopes. However, the process of building foundations on terrain which features such as coastal slopes encounters several difficulties. Coastal waterlines, whether natural or artificial, and subject to destructive factors such as wind, precipitation, and water. Tides, floods, and other natural phenomena contribute to processes of degradation that can have adverse consequences. Destruction is caused by various natural phenomena such as waves, water surges, eddies, and zigzagging sections of the watercourse, and so forth. Preserving sensitive soil through its stabilization has become a priority task. To mitigate these problems, measures need to be taken for the reconstruction and reinforcement of coastlines. Special attention is also given to protecting the soil, a valuable resource that plays a crucial role in maintaining biodiversity and carbon balance. Soil erosion caused by the influence of wind, rain, and gravity becomes a pressing issue that requires stabilization and protection in various sectors, from agriculture and private projects to the oil and gas industry, from protecting coastlines to recovery after natural disasters. The geological foundation of the construction site is a crucial characteristic. Designing buildings on coastal slopes requires careful consideration of soil types, their mechanical properties, and hydrogeological aspects. A thorough analysis of geological data is key to identifying potential engineering challenges and determining optimal foundation methods. Designing buildings on coastal slopes demands creative solutions to seamlessly integrate structures into the natural landscape. Innovative approaches in engineering allow for the development of effective and environmentally friendly solutions to protect the coastline and create comfortable conditions for the residents and tourists. Given the exaggeration of the environmental issues and the need of the sustainable development, finding effective solutions for engineering coastal slopes becomes extremely important. Scientific research on the architectural aspects of coastal slope development goes beyond mere aesthetic consideration in constructions. Despite numerous advantages, designing on sloped areas poses complexities in planning and executing construction projects. Steep slopes face initial challenges with airflows, which can be uncomfortable for residents, especially during cold and wet seasons when harsh winds prevail. Another aspect to consider in construction on such slopes is drainage. A separate issue on steeply sloped areas is soil stability. In the best case scenario, if a house isn't anchored in the ground, it can gradually slide down the slope by 10-15 centimeters per year. This is particularly true for sandy or clay soils. In terms of construction, building technology on slopes requires some special approaches to ensure stability and safety. When introducing a building on a slope, it's important to consider the specifics of the soil and landscape to avoid potential stability issues with the building. Unevenness in the terrain can cause difficulties in evenly distributing the load on the building's foundation. This can lead to improper settling, tilting, and the appearance of cracks in the buildings. Therefore, it's essential to consider the characteristics of the foundation first and foremost. The use of different types of foundations may be necessary depending on the soil characteristics and the steepness of the slope. Cascade foundations, for example, can be a beneficial option for ensuring even distribution of load and preventing buildings slippage, as well as for the achieving maximum uniformity in the depths of support areas. Developing proper site geology and conducting engineering geological surveys are crucial in this process. Only a thorough analysis of soil structure will allow for the selecting the optimal foundation type for a specific location. Highly skilled experts with deep knowledge of soils in their properties are required for implementing such projects. Cascade foundations have some commonly accepted standards. For instance, the stability of the foundation should be at least 1 meter, and the cascade itself should be larger than half the stability, which typically ranges from 2 to 4 meters. Working reinforcement serves the function of load transfer and resistant to bending and strengthening, while structural reinforcement is carried out in the central part of the foundation. The analysis of architecture technologies for building on slopes relies on a thorough study for the specific characteristics of this type of construction. Considering important rules and their compliance with the specific conditions of the site and crucial in ensuring the most reliable foundation structures. The steeper the slope, the greater the risks regarding soil stability. In the case of the slope within 10%, the soil tends to be more stable. During the analysis of architecture technologies for building on steep slopes, the primary focus is on studying methods of soil stabilization in increasing slope stability. One approach is the use of geotechnical systems, which involves the use of geosynthetic materials and engineering structures to engage soil drainage and prevent erosion. One possible method of construction on slopes is the use of cascade foundations. This method involves placing foundations at different levels, allowing for even distribution of loads and ensuring structural stability. However, drawbacks of this method may include complexity in execution and high construction costs. Another common method is the use of pile foundations on driven reinforced concrete piles. This approach effectively addressed issues with weak soil, ensures structural stability even on slopes with significant height differences and rising groundwater levels in hard-to-reach areas. However, successful application of this method requires additional soil investigations and consideration of site-specific characteristics. For a site with varying heights, pile foundations on driven reinforced concrete piles are the most optimal option for implementation. Ensuring a horizontal plane for the foundation on a sloped site is only possible by smoothly adjusting its height. For sites with significant slopes and problematic soils, pile foundations on driven reinforced concrete piles are the right choice. Problematic soils refer to soils prone to seasonal hardening, saturated with moisture, and challenging by significant frost depth. The analysis of soil works is a crucial stage in investigating the architectural aspects of construction on coastal slopes. In this subsection, we will carefully examine various aspects of soil works, including site preparation, soil stabilization, and erosion protection. This will provide us with a deeper understanding of the impact of soil processes on structures and allow us to develop optimal construction strategies to ensure the strength and durability of buildings on coastal slopes. Researching the architectural aspects of construction on coastal slopes has proven to be a complex and multifaceted process requiring the integration of knowledge from geology, engineering, and architecture. The main objective was to determine optimal methods and construction technologies that would ensure the strength, stability, and durability of buildings on coastal slopes. Therefore, the development of constructive solutions for construction on coastal slopes requires a comprehensive approach and careful analysis of geological, engineering, and architectural aspects. This research helped understand the complexity of this task and develop optimal construction strategies to ensure the stability and safety of building structures on the coast. Thank you for your attention.